Today's lesson is section 6.1b, still talking about angle measure. Some things to know, or variables to know, are these Greek letters. The one that is over here, Greek letter for A, is called alpha. The capital letter for, or capital Greek letter for B is called beta. And I believe the lowercase letter for Y in Greek letters is gamma. And then this one that just looks like a cursive W is called omega. Okay, these are the four variables that we'll use when it comes to talking about angles in any time with trigonometry, especially if we were saying cosine of some angle. We wouldn't usually, sometimes you'll see x or t, but you'll also see alpha, beta, gamma, and omega sometimes as well. Gamma comes into play when we're talking about the next section, angular and linear speed, or the next section of this particular part of the section. Okay, so just to keep an open mind, know that those are just variables, not something ridiculously outrageous. Okay, two things we'll talk about in this video will be arc length and area of a circular vector or sector. Arc length is when in a circle of a radius r, okay, the length of S of an arc that subtends a central angle, or is connected to central angle of theta radians, is S equals R times theta. Okay, so what that looks like is if I have a circle, my center is here, okay, so radius R, and if I have a central angle, so subtends means it comes from, we have theta here, okay, then this part on the circle, this length, is your arc length, and we'll represent it as S. Now one thing to remember is that theta with arc length and the area of a circular sector, when we use theta in these, your theta must be in radians, okay, or it won't work. Plus you'll get an outrageous answer if you have it in degrees. So anytime you're given problems that start with degrees, you'll need to change them to radians before you can continue. Okay. One other adaptation of the arc length equation, you can also change it around so that you can find the angle using the arc length. So we just divide both sides by r, and so you get theta equals S over r. Okay, so that's right here. So then from there, we want to do some examples. So example 5 says find the length of an arc of a circle with radius 6 centimeters that subtends a central angle of 100 degrees. Okay, so that means that you have there's 100 degrees, our radius is 6, okay, so then we want to find S. Now, like I said before, we need to change degrees to radians before we can move on. So that means that I need to multiply using pi over 180. Remember, since I want radians, I want pi to be in the numerator, so it stays, okay? Because degrees go away, and I can reduce, looks like by a factor of 10, also by a factor of 2. So then I'm going to have 5 pi over 9 as my radian measurement for 100 degrees. So then now, using my formula, since I want to find S, take R times theta. So R was 6, and then times 5 pi over 9. Remember, this is 6 is a fraction as well, 6 over 1. So I can reduce by making it to 3. So then that gives me 10 pi over 3. Okay, so the radian measurement of the arc length is going to be 10 pi over 3 radians. Okay, so that's the first example with that. Another example with that is kind of doing the other way. You want to find the angle. So a central angle theta in a circle of radius 9 meters is subtended. Oh, and that reminds me, since we were given centimeters, it shouldn't be radians. It should be centimeters here. Sorry about that. Go back. So then a central angle theta in a circle of radius 9 meters is subtended by an arc length 3 pi over 4 meters. Find the measure of theta in radians. So now we're going to use the other one. Since you're given the arc length and the radius. Now here, your stuff is already in radians, so we don't have to worry about anything. So then now, I took 3 pi over 4 divided by 9. Now both are in meters, and those cancel each other out. So what you're left with is radians, okay? You don't have to change it to anything. The nice thing with radians is that every measurement that we use, like an actual distance, like a meter stick for, so like miles, if they ended up canceling out, it doesn't become units, really. It's actually radians. So radians is always a hidden measurement or hidden part of all our stuff. So since we cancel out meters, it now is radians no matter what. Which is nice because now you don't have to like do something magical to make it radians. It already is. Okay? So then here I have a complex fraction because I have a fraction in the numerator. So then 9 over 1 I need to write in the denominator. So that means I need to multiply by the reciprocal. So I keep 3 pi over 4 the same. I'm going to flip 9 over 1 and make it 1 over 9. That means I can reduce. So then now I get pi over 12. And that'll be in radians. So my angle should be pi over 12. So there's a very small angle. I think that's about 15 degrees. Okay. Moving on. Now we'll talk about area of a circular sector. This is in a circle of radius r. The area A of a sector with a central angle of theta radians is A equals 1/2 r squared times theta. Okay, remember that theta must be in radians. So an example of using this, and I want to find the area of a sector of a circle with central angle 50 degrees if the radius of the circle is 8 meters. That being said, if I have 5 or 50 degrees, remember I got to change that. So pi over 180. 5 and 18 don't reduce any further, so I get 5 pi over 18. Okay, so that'll be my radian measurement. So then from there, now I just need to plug in my stuff. So area equals 1/2 r squared theta. So r is 8 squared times 5 pi over 18. Okay. Here, I can try to simplify a little bit. I got 64 it looks like 64 and 2 reduce. That gives me 32. I think I can take out a 2 here. So it gives me 16. That gives me 9. There's only 2's and 16. There's only 3's and 9. So then they just stop right there. Okay, so then now I want to multiply across. So 16 times 5 gives me 80 pi over 9. And then that will be in meters squared, since we're talking about area of a two-dimensional shape. Okay? So that is what we'll be asking you for arc length and area of a circular sector. Okay? Have fun.